Dear students, in this video we are going to study about the instrument called as potentiometer and how we can use this potentiometer to compare the EMF of two given cells, and also about the determination of internal resistance of a cell by using a potentiometer. Now let us study about the potentiometer. This is an instrument which is used for the accurate measurement of potential differences, current and resistances, and this instrument consists of a 10-meter long uniform wire of manganese or constantin set in parallel rows, each of 1 meter length, on a wooden board. The two free ends A and B are brought to the same side and fixed to copper strips with binding screws. A mirror scale is fixed parallel to the wire. The jockey is provided for making contact. The principle of the potentiometer is illustrated in the figure 2.27. The steady current is maintained across the wire CD by a battery BT. Battery key and the potentiometer wire connected in series form the primary circuit like this. This is primary circuit on this side. The positive terminal of a primary cell of EMF E is connected to the point C, and negative terminal is connected to the jockey through a galvanometer G and a high resistance HR. Here. This forms the secondary circuit. Let the contact be made at any point J on the wire by the jockey. If the potential difference across Vj is equal to the EMF of the cell E, then no current will flow through the galvanometer and it will show zero deflection. Cj is the balancing length L. The potential difference across Vj is equal to IRL, where I is the current flowing through the wire and R is the resistance per unit length of the wire. So E is given by IRL. Since I and R are constants, so E is directly proportional to L. The EMF of the cell is directly proportional to the balancing length L. Next, we are going to study about the comparison of EMF of two cells with a potentiometer. To compare the EMF of two cells, the circuit connections are made as shown in the figure 2.28 like this. Potentiometer wire CD is connected to a battery BT and a key K in series. This is called the primary circuit. Here, this is called the primary circuit. Battery, key, rheostat. The NC of the wire is connected to the terminal M of a DP-DT switch. This DP-DT switch is called a double pole double throw switch. And the other terminal N is connected to a jockey through a galvanometer G and a high resistance. The cells whose EMF E1 and E2 to be compared are connected to the terminals M1, N1 here and M2, N2 of the DP-DT switch. The positive terminals of BT, E1 and E2 should be connected to the same NC here. Then the DP-DT switch is pressed towards M1, N1, so that cell E1 is connected in the secondary circuit, and the balancing length L1 is found by adjusting the jockey for zero deflection. Then the second cell E2 is included in the circuit, and the balancing length L2 is determined. If R is the resistance per unit length of the potentiometer wire and I is the current flowing through the wire, then E1 can be written as IRL1 and E2 as IRL2. And dividing the equations, we have E1 by E2 equal to L1 by L2. So by including a rheostat RH in the primary circuit, we can adjust the value of current, and the experiment can be repeated several times by changing the value of current flowing through the potentiometer wire. Now we can also use the same potentiometer for the measurement of internal resistance of a cell. And to measure the internal resistance of a cell, with the circuit connections are made like this, as shown in this figure. The NC of the potentiometer wire is connected to the positive terminal of the battery BT, and the negative terminal of the battery is connected to the D through a wire and through a key resistance, that is C, and this forms the primary circuit. The positive terminal of the cell of EMF E, whose internal resistance is to be determined, is also connected to the NC of the wire, and the negative terminal of the cell E is connected to a jockey through a galvanometer and a high resistance. A resistance box R and key K2 are connected across the cell E. With K2 open, the balancing point J is obtained and the balancing length Cj equal to L1 is measured. Since the cell is in open circuit, the EMF is given by E proportional to L1, directly proportional to L1. And suitable resistance about 10 ohms is included in the resistance box, and KT2 is closed. Let R be the internal resistance of the cell. Current passing through the cell and the resistance R is given by A equal to E by R plus R. Potential difference across R is given by V equal to ER by R plus R. When this potential difference is balanced on the potentiometer wire, let L2 be the balancing then now. Then ER by R plus R is diagonal proportional to L2. So from the equation 2.62 and 2.63, we have this equation R plus R by R equal to L1 by L2. So 1 plus R by R equal to L1 by L2, or the internal resistance R is given by capital R. The resistance R is the known value of resistance multiplied by L1 minus L2 by L2. So substituting the values of the known resistance R, balancing length L1 and L2, the internal resistance of a cell can be determined. This experiment can be repeated for different values of the known resistance. And it is found that the internal resistance of a cell is not constant but increases with increase of external resistance connected across its terminals.